Hello everyone, I am Sahana, Assistant Professor, Physics Department, Srinivas Institute of Technology. Today we are going to discuss about Applied Physics for EE Stream, Module 5 Semiconductor Device. In that we are going to discuss about, I will be explaining about photodiode and its power responsivity. Photodiode is a two-terminal semiconductor optical device that responds to an incident light by setting a current in the circuit. Any device which converts optical signal into corresponding voltage or current signal is called optical detector. Hence, a photodiode is an optical detector and finds immense use in the fiber optic applications. In optical fiber applications, this photodiode is used. See, this is the symbol for photodiode. See, this is the symbol for photodiode. So here it will absorb the light and it will convert that to electrical energy. Now let us see the construction. See the figure. This is the construction. A photodiode is always operated under reverse bias. As any semiconductor device diode, it is also PN junction diode with depletion region at its central part. But because of the reverse bias, the depletion region is widened. Here in the figure you can see the depletion region widened. So that is due to the reverse bias condition. In case of an ordinary diode, its surface is fully covered by some coating. But in case of photodiode, there will be a partially transparent cover so that the light from outside may be incident on the depletion region. Let us see the working. When light is incident, it is considered as stream of photons. Some of the incident photons are absorbed by the neutral atoms in the depletion region, giving rise to production of electron-hole pairs. Instantly, inside the depletion region, the electrons are pulled towards N region and holes to the P region, since the N part is connected to positive hole and P part to the negative hole of the battery. But when electrons arrive at the N region, they are repelled by free electrons. They are already present there because electrons are already present there as the majority charge carriers. Similarly, when holes reach the P side, they are repelled by the holes which is already present there as the majority charge carriers. So, these newly arrived electron holes pile up at the inner boundaries of N and P sides, which results in building of EMF between the two sides, which acts as a potential barrier. If the battery voltage is raised so as to overcome the barrier, the current starts flowing. It is called photocurrent, which increases with increase in the intensity of the incident light. You can see in the figure that. So thus, photocurrent is proportional to intensity of the incident light. You can see that in the graph. If you are drawing a graph of current versus voltage, you can identify this. Now, due to the applied reverse bias, there will be a very small current flowing in it, even when there is no light falling on it. It is called dark current and it is defined as it is the current flowing through a photodiode under an applied reverse voltage in the absence of light. The dark current arises because of majority charge carriers produced in the photodiode due to the heat entering from outside, and this current is more under hot weather conditions. In forward bias conditions, the current in the diode will be in milliamperes. So that is the reason why photodiode always it is operated under reverse bias, because in forward bias condition we will get the current only in a small quantity in milliamperes. Now let us see what is responsivity. Responsivity is indicated as R lambda. It is the ratio of output current I in amperes to incident that is optical power, that is capital P. R lambda is equal to I by P ampere per watt. The variation of LED power and photodiode current it is shown in the graph. You can see that in the graph a straight line is obtained and the slope of that gives responsivity. So external conversion efficiency of LED is 0.66. So that is why we have to divide by 0.66 to get the exact value of responsivity. So responsivity R lambda is equal to slope divided by 0.66. So using this you can calculate the responsivity of the photodiode. So thank you. Today we will end this topic. Thank you for listening.